Hello. Now, currently the time is going to be 6 o'clock, and I'm going to start sample papers because sample papers is where they're going to choose the question papers from. So, you should be pretty intelligent enough to solve all of that and to really look through each and every questions and answers as well. So, I hope this video will help you to look through all the sample questions and the answers. Okay, without any delay, let me start. First one is the first sample paper. And over here I have the solutions. So let's go through every single sample paper as much as I could till 12 o'clock. Okay, now I'll go really fast, but still I will be very clear because I'm going to use video for my pre-board exams, final exams, and my board exams eventually. So I want this to be proper. So let's start. So from first uh, this is how the paper is going to be like. Every time they'll give you instructions, you have to know that you have almost A, B, C, D, E. You have totally 5 sections, and then each one of the section carries each number of marks and different numbers of questions that you have to attempt. So first one, starting with section A, where we have MCQs. Let's start. So first they're giving us. Usually, I think sample question paper is a bit easier and just simply from book or something that we have studied from 10th. I think it's easy, so let's go on. Okay, let's start. Section A, first question. If a bar magnet is dropped down in an infinity long vertical copper tube, then the magnet will move continuously. Okay, so they've given us will move continuously. Okay, so that we have to give the answer. Increasing velocity and decreasing. So answer is it will increase velocity but constant acceleration. We know that when a bar magnet is dropped down an infinitely long vertical copper tube, its velocity continuously increases due to the gravitational attraction. As a result of this, the velocity of the bar magnet continuously goes on increasing, but having the constant acceleration due to free fall under gravity. Okay, so now let's go to the second question. They have given us this image, which is in the first chapter of a book. So they've given in figure a positively charged glass rod is brought near a negatively charged plastic rod. Okay, what does the resulting interaction imply about the forces between them and the options? Okay, the answer is B. The rods attract, indicating the forces between opposite charges are attractive. The glass rod is positively charged and the plastic rod is negatively charged. The diagram shows that they pull towards each other, confirming the principle that unlike charges attract each other through electrostatic forces. Okay, now third question. The circular coil of radius r carries the current I. The magnetic field at its center is T. At what distance from the center on the axis of the coil the magnetic field will be B by 8. So we should find at what distance. So let's see. There's a formula that is B is equals to magnetic field at center divided by 8 because they've given us this is what they've given. Okay, so this is the axis. So B axis is equal to B by 8, and then the formula which is mu naught n I r square divided by 2 times r square plus x square to the whole power 3 by 2 is equals to 1 e divided by 8 times 2r, which gives us 8r cube is equals to, this goes this side I guess. No, the top thing gets cancelled and this r is going up there and making it r cube, and this comes over here, so we get r square plus x square, which is and we are finding it out to be root 3. Okay, so hence root 3 r distance from the center of the magnetic field is equal to the magnetic field at the center. Okay, root 3 r. Next is the voltage V and current I graphed for the conductor at two different temperatures Ti and T2 are shown in the figure. The relationship between Ti and T2 is, by seeing this image we should say which is greater and which is less. So the answer is So the answer is T1. Look here, T1 is greater than T2. We know by Ohm's law that the resistance of the conductor, that is R, is equal to V by I. We also know that from the figure V by I is the slope of the VI graph. Since V divided by I1 is greater than V divided by I2, therefore R1 is greater than R2. We also know that the resistance at a temperature T, R is equals to, this is a formula that we have to find for the temperature, I guess. So R is equal to R naught in the brackets 1 plus alpha t, which is proportional, directly proportional to t. So from this equation we can say that t1 is greater than t2. Okay, now next fifth question that we are going to move. Two plates of the parallel plate capacitors are 1 centimeter apart from the potential difference between them is 10 volt. Then the electric field between the plates is, we should find what is the electric field between them. Okay, so it is, the answer is option D, it is 1000 newton coulomb per second. The distance, the so as it's given, the distance between them is d is equal to 1 centimeter, which is 0.01 meter, and with the potential difference between them is v is equal to 10 volt. We know by electric field by between two plates in the parallel plate capacitor, e is equal to v by d is equals to 10 by 0.01, which is equal to like 1000 newton by capacitance. So now next, moving to the sixth question. Two coils are placed close to each other. The mutual inductance of the pair of the coils depends on what is the mutual, like with that formula we can also find, but even if you remember through concept you can also say. So two coils are placed, so it's the option C, the relative position and the orientation of the coils. This is what it depends on. Okay, the relative position and orientation of the coils. We know that the mutual inductance of a pair of coils depends on upon the geometry of the coil, distance between the coils, relative position and the orientation of the coil, the number of turns in the coils, and the permittivity of the medium which the coil wounded, in the degree of the coupling, that is the extent to which the magnetic flux primary current links to the secondary. So next, going to the seventh one. What happens if a monochromatic light used in Young's double slit experiment is replaced by white light? Okay, we know what is white light and what is monochromatic light, isn't it? Okay, they're saying only central fringe is white, all other fringes are colored. Because we know that in white light, okay, in white light is, it consists of seven colors, and when it goes up from a part, it slowly shows colors. So that's what they're trying to say over here. Okay, we know that if white light is used in Young's double slit experiment, we get a central white fringe because all the wavelength of white light is zero path difference, and other points of the between both sides of the central white fringe have different path difference of different wavelengths of white light. Therefore, no condition of brightness or darkness is satisfied. As a result of this, colored fringes are observed on both the sides of the central white fringe. Okay, now next, moving to the eighth question. Okay, eighth question, they're asking an electric current passes through a long straight copper wire at a distance 5 centimeter from the straight wire. The magnetic field is B. The magnetic field at 20 centimeter from the straight wire will be. Okay, the answer is B by 4. As you know, the distance from the point of the wire is 5 centimeter, and the magnetic field at the first point is b1 is equals to b, and the distance of the speed of the point from wire is r2 is equals to 20 centimeter. We know that the magnetic field due to the current carrying long straight wire at the point is b is equals to mu naught by 2 pi divided by I by r, which is proportional to 1 by r. With this, we can say that b1 by b2 is equals to r2 by r1, which is equals to 20 by 5, which is equals to 4. So b2 is equals to 1 by 4, thus it's equals to b by 4. Okay, now next, ninth question. An aluminium ring B faces an electromagnetic A. Which of the following statement is true? So we can see the image over here. So AGB is a aluminium ring, and this is an electromagnet that we have. So what is the correct statement from this image? So the answer is A. If I increases, A will repel B. We know that when the circuit is closed, increasing current in the coil of electromagnet A produces the time varying the magnetic flux which magnetized it. We also know from Lenz's law that when time varying magnetic flux links with nearby ring, then direction induced current or EMF in the ring will such that it possesses the cause which produces it. Okay, because of Lenz's law. Okay, that we remember. Next 10th question. A particle of mass m and charge q is accelerated toward a potential. The de Broglie's wavelength of particle will be. So they've given us everything. We should find what is a de Broglie's wavelength. So the answer is C, h divided by root of 2qmv. A particle of mass m and charge q is accelerated through a potential v. Kinetic energy gained by the particle is equals to k is equals to half mv square is equals to p square divided by 2m. Work done on electron is equals to qv. Hence p square by 2m is equals to qv. P is equals to under root of 2mqv. Hence de Broglie's wavelength of particles, that is lambda is equals to h by p is equals to h by under root of 2mqv. And also we know the minimum angular momentum of an electron. In hydrogen atom, the minimum angular momentum, according to Bohr's atomic model, electrons are permitted to circulate only in those orbits in which the angular momentum of an electron is an integral multiple of h divided by 2 pi, h being a Planck's constant. L is equals to nh divided by 2 pi and n is equals to 1. Thus L is equals to h by 2 pi, hence the minimum angular momentum of an electron in hydrogen atom will be h by 2 pi. Okay, next 12th question. In the figure, if the net force on Q is 0, then the value of Q by small q is Q by small q, Q by small q. The net force Q by small q is equals to 2 by root 2. Let's see the, because according to the question, the force is Q by Q in the triangle ABC. According to the Pythagoras theorem, AC square is equals to AB square plus BC square. AC is equal to under root of A square plus A square, which is equals to root 2A. We know that the resultant force Fr is equals to root 2 under root of F1 square plus F2 square according to Coulomb's law. F1 is equals to KQQ by A square. F2 is equals to KQQ by A square. So F3 is equals to KQQ divided by root 2 of A the whole square. So the square gets cancelled, that we get kq square by 2a square. From this equation we can say Fr, that is resultant force, is equals to under root of kqq by a square plus kqq by a square the whole square is equals to kqq by a square the whole square into 1 plus 1 will give us this answer 2 root 2. Okay, next assertion and reason. The assertion says the photosensitive of a metal is high if the work function is small. Okay. The reason is the work function is equals to HFO, where FO is the threshold. I think it's wrong. Yeah. Okay, the answer is B. Both. Oh, it's correct. Work function is this. Okay. Even this is correct. Okay. Work function. Okay. Both assertion and reason are correct, but the reason is not correct explanation of the assertion. The photosensitivity of metal is high when the work function is small. The work function of a metal depends on the threshold frequency but not on the nature of the metal. Okay, 14th one. In Young's experiment, the fringe width of dark fringe is different from that of white fringes. Reason in a Young's double slit experiment, the fringes are performed with the source of white light, then only the black and white fringes are observed. I think 14th one reason is wrong. So, okay, answer is D. Both assertion and reason is incorrect. In Young's experiment, fringe width of dark mm, and white fringes are equal. If white light is used of the source, the colored fringe are observed representing the bright band of different colors. Okay, 15th one, the resistivity of semiconductor increases with temperature. The reason is atoms of semiconductors vibrate with large amplitude as higher temperatures, thereby increasing resistivity. The answer of 15th one is D. Both assertions and reason are incorrect. The resistivity of semiconductor decreases with increase in temperature as more electrons jump into conduction band, increasing its conductivity. Okay, next sixth one assertion: the minimum distance between the object and its real image formed by convex lens is 2f. Reason: the distance between an object and the real image is minimum when the magnification is 2. Okay, answer is C. Assertion is correct, but reason is incorrect. The distance between object and its real image is minimum when magnification is 1. We know that the magnification of convex lens is thereby by m is equals to minus v by u. For m is equals to 1, v is equals to minus u. Now by lens formula, v is equals to u is equals to 2f. Hence the minimum distance is v plus u is equals to 4f. Okay, now next moving to the 17th question, which is a 2 marker. You are given two converging lens of focal length 1.25 cm and 5 cm to design the compound microscope. If it is desired to have a magnification of 30, then find out the separation between the objective lens and then eyepiece. Okay, so they've given the question here. The answer is, so we know the objective lens is 1.25 centimeter. Okay, and eyepiece is 5 centimeter. And the magnification should be 30. Then uh, D is equals to 25 centimeter. If the objective is very close to the principal focus of the objective and the image formed with the objective is very close to the eyepiece, then the magnification power of the microscope is given by m is equals to 1 by f into d divided by f2. 30 is equals to 1 by 2, 1.25 into 25 divided by 5. I think there is a formula for diopter. They didn't give the formula for diopter here. I think diopter is equals to 1 by f. Okay, let's move on. M is equals to 1 by f naught dot t by f2. So 30 is equals to 1 by 1.25 into 25 divided by pi. This L is equals to L is equals to 1 by 1.25 into 30. How did L come here?